Greetings, Joanne Myers here, Financial Math, Chapter 10, Math 1160. We're using the Pearson book, My Lab's Math. Chapter 10 is compound interest, inflation. I'm going to go through the PowerPoint provided by Pearson here quickly. You can pause the video if you'd like more time to read what's on the slide, or obviously rewind. We're comparing and contrast simple interest and compound interest. Determining the interest rate if we give you the compounding periods, the number of compounding periods or an investment, practicing compounding future values. Simple interest, I equals PRT, interest equals principal times rate times time. Please note and remember that the rate is the interest rate. The interest rate must be written as a decimal. So if I have 6.2%, that would be 0.062. In math, you're always allowed to multiply or divide by 1. 100% is 1. That's how you know to convert the percent to a decimal. Time. Your time must always be in years. When grading, if your simple interest is wrong, the first place I check as an instructor is, did you use time in years? So in other words, if you're given 6 months, then you need to know that that is half of a year. If you want to use dimensional analysis, 6 months, you can multiply by the ratio of months to years. 1 year is the same thing as 12 months. So 6 months is the same thing as half of a year. This will work whether you're given 2 months, 3 months. If I'm given 14 days and I need to convert that to years, then I know 1 year is 365 days. So my fraction, throw it into a calculator to get your decimal. 14 days is the same thing as 14 365ths of a year. Later future chapters, you'll use banking years, which is 360 days. But at this point, we're still 365 days per year. Future value. This depends on your compounding interest, the interest rate, the length of your investment. Obviously, compounding interest. If I add interest to your account every month, that means I'm paying interest on the interest I paid you previously. So compounding interest will get your bank account to grow faster than simple interest, where I just plunk in the amount each year. Your future value will increase. Your compounding period is the time over which the interest is calculated and then added to the principal. So if I am compounding monthly, my compounding period is every month because I figure out how much the interest is calculated over that month, and then I add it at the end of the month. The number of compounding periods, this is your N in the equations for this chapter. It's the number of compounding periods, either in each year or over the life of the loan. The interest rate is the interest rate applied to each compounding period. It's found by dividing the annual interest rate. This is important. It's found by dividing the annual interest rate by the number of compounding periods in the year. So if I'm compounding monthly and I have an annual rate of 5.4%, then my I will be 0.054 divided by 12. I'm looking too, sorry about that. All right. That's how you would compute your I. The total number of compounding periods is the product, which means multiplying, of the number of years and the number of compounding periods. So N equals your number of years times the number of compounding periods per year. So multiplication of fractions. So if I have 5 years, and monthly compound situation going on, then I would have 5 years times 12 periods per year. So my N would be 60. And that's what I would put into my equation. All right, find the interest rate per compounding period, the number of compounding periods for each. 5% compounded semi-annually for 3 years. Semi-annually tells me 2 times per year. So my interest rate is 0.05 divided by 2, which is 0.025. And my N is 3 years times 2 periods per year. So my N will be 10 periods. %6 per year compounded monthly. Compounded monthly. My I will be 0.06 divided by 12. My N will be 2.5 years, 2.5 years times 12 periods per year. So my N is 30. 2% per year compounded quarterly. There are 4 quarters in a year. So 0.02 divided by 4 is my I. My N is 5 years times 4 times per year. So my N is 20. Again. Maturity value. All right. The mature value, the total amount of your investment is going to equal the amount of money you put in to begin with, your principal, times 1 plus your interest rate. Again, your I is still computed by the interest rate per compounding period. So read the question. Is this an annual interest rate? And they're adding the interest annually, then your I is the I they gave you in the word problem. If your interest is compound quarterly, then take your annual interest rate I and divide it by 4. And then N is still the number of compounding periods. It is not the number of years. It's the number of years times the number of times they add the interest each year. Okay, bank formula, an investment bank at Bank of America pays 7% interest, or investment pays 7% interest per year, compounded semi-annually. Given an initial deposit of $4,500, A, use the formula to find the compound amount after 5 years, and B, find the compound interest, round to the nearest cent. Semi-annually, that means twice per year. So, A, your interest is compound at 7% and added to your account twice per year. So this is your I. How many compounding periods do you have? 5 years times 2 periods per year is 2 periods. So your N is 10. Plug them into your equation, plug them into your calculator. Basic math. Order of operations matters. You need to do what's in the parentheses first add the 1 and your decimal point, then raise it to the n power. On your calculator, if you don't have even if you have the fancy financial one, if you have a general TI, Texas Instrument, or any type of calculator, if it has a y to the x power, this button right here on your calculator will allow you to raise whatever decimal you have on your screen to whatever n value you need. In this case, it's 10. All right, compounding amount is here. Now to find the interest, it's the mature amount minus the principal that you initially put in. So we found that our M was $6,347.69. And then our initial investment was $4,500. So here's our interest. Again, pause the video if you need some time to process this. Here's the example using your financial calculator, how you'll put the information in. Again, pause if you'd like more time to look at this. We don't do much in section 2, so we're jumping right to section 3. 2 equations here. Present value and future value. We're comparing the future value and the present value. Future is how much money will you have at a specific time in the future, when you retire, when your kids go to college, when you want to buy a car in 3 years. What will the future value of the account be if I invest a certain amount now? The present value says, if I want to have $10,000 in 3 years, what is the present value that I need to put into my account right now? What do I need today so that in 3 years I have $10,000 saved up? That's what the present value is asking. It's not what does my bank account look like now? It's what do I need my bank account to look like now? Or what amount do I need? What is the present value I need now so that I can have X amount in the future? Future and present value are related. Here's the formula. Present value is M, the mature value, divided by 1 plus I to the N. Well, I'd like to remind you, we had an interest equals principal times 1. No, I'm not going to go there. Sorry. My hint again in this course is to compare the new equations to what you know before and see if it's an entirely new equation or if it's something that you already have stored in your brain. If it's already using space, attach the new to the prior knowledge. This will help you access all of the information more quickly. Notice the relationship between these 2 equations. The mature value is the present value times 1 plus I to the N. The present value is the mature value divided by 1 plus I to the N. My 2 favorite things in all of math is you can do pretty much whatever you want to both sides of an equation, except divide by 0. So I can divide by 1 plus I to the N and 1 plus I to the N, and notice that these 2 equations are really the same thing. You can memorize 2 separate equations, or you can memorize 1 equation and remember some basic algebra of multiplying or dividing the same thing to both sides of an equation. Again, we've gone over what these values mean. Total number of compounding periods is your end, and the interest rate per compounding period. Local Harley-Davidson shop has seen business grow rapidly. The owners plan to remodel the shop in 1 year at a cost of $280,000. How much should be invested in an investment earning 6%? Here we go, 6% compounded semi-annually in order to have our funds needed. So on the test, it's not going to say this is a present value formula. You have to figure that out. How do I know? Well, I know that a year from now, they're going to need $280,000. So if I'm their financial advisor, how much do they need now in the present? that's going to be my present value equation. So that's the one I need to pull out of my memory or take off of my chart if I'm working and have a formula sheet. So here we go. Find the amount of interest earned using this formula. Okay, so step one is find the present value. What do they need now? Step two is find out how much interest they'll earn. All right. My I is the 6%, 0.06 semi-annually. So that's going to be 0.03 that I use for my I. My compounding periods, 1 year times 2 periods per year. So my N is 2. So my I is 0.03. My N is 2. Plug it into your calculator. This is the amount needed now. This is what I need now to have that 280,000 in the future. You can plug it into your calculator if you like. Again, pause the video, read the steps. The second part says, well, what was the interest? Well, if this is your present value or your starting principal, another word for this one would be your starting amount. Here's your final amount. Well, then clearly the interest is the difference where you subtract those two. So here's your interest. Next example. If the business is expanding and it wants to invest money today with expected growth goal in the future, estimate the future value of the investment. Then find the present value using your discount rate. Village Hardware expands its business at a cost of $20,000. They expect the investment will grow at a rate of 10% per year compounded annually for the next 4 years. So 10% per year compounded annually. So that's telling my interest is, and then for the next 4 years, I'll get it on the next page. You're going to find the future value. The present value formula, and then part B. All right. Your future value. It's the same thing as your M, your mature value. The future value is the same thing as your mature value. It's the same equation you've been using. The N is 4 because it's compound annually for 4 years. Your I is 0.10. Plug it in. There you go. Finding the same information with the calculator. There you go. Part B. Now you need to find the present value that you need in order to have that amount. So let me go back to where we're talking. Our original question. Okay. Our I is 0.10. Our N is 4 times 1, which is 4. Use the present value formula to find the present value needed once I figured out how much money I need to have saved up in 4 years. So what's going on here? Present value of $29,282 if I now have a 6% loan compounded annually for 4 years. So if in 4 years, I really need $29,282, then the money I need to invest right now is $23,194. Now, if you're using the MyLabs math, read the directions whether you are asked to round to the whole dollar or round to the cent, having 2 decimal points or 2 decimal places. MathLab is picky about that. Make sure you and MLM are speaking the same language, or you can do all the computations correctly and get the wrong answer and be frustrated. Do use the Ask My Instructor email key to send copies of the actual. If you use Ask My Instructor, if your instructor has that enabled, then it will send an email to your instructor that already has a copy of the exact homework problem you're working on, which makes it easier for them to respond in greater detail. All right. Again, you can use it with your calculator. If you have questions, email your instructor. Glad to help.